All right, we're getting started.
So like that, should be down a lot.
All right, is that good? Hello?
Two games.
All right. All right, we're getting started right now. Everyone's ready? Cool. All right, welcome everyone to Space City Rocketry's meeting for October 12th, 2021. And the agenda today, we have a few things. We have upcoming events. This weekend, we have two things planned, and we'll be talking about it. Also, shout outs, like every week. And then we have a really fun Kahoot. I hope everyone's gonna enjoy it, and sub-team updates. And then it's not here, but at the very end, we do have a lesson that we're gonna be going over. So for upcoming events, so as I mentioned last week, this weekend in Herman Park, we're gonna have a social from 4 p.m. to 8 p.m. It's gonna be a potluck. Members can just bring food. We're gonna create a list so everyone can bring something different. And we're gonna be sending it out to the Discord. Some other things that we wanna do every weekend too is Fridays at Pink's. So if anyone is ever down to get dinner on a Friday to end the week from 5 to 6:30 p.m., just send a message on the Discord and we'll be going there and heading over there with you. Sunday Scaries is another thing we brought up last week. It's basically every Sunday, right before the week starting, people usually get scared and anxious about the week and what we have coming up. So in order to relax, maybe we want to do homework or just hang out together at the Nook from 8 to 10 p.m. If one person sends a message, everyone else can show up. And then study sessions, we're still planning those. But if anyone wants to ever study, you're at the library, you're at SR1 on the second floor, or at the lab, just send out a message and we can study together. Now, Ravi, you want to talk about Cub Scout this weekend for AAA?
Hello, everyone. This weekend on Saturday, October 16th, we will be supporting the Cub Scouts and their model rocket launch. It is with Pack 1537 near KD, somewhere in that area, about 40 minutes away from U of H. They have requested that some of us be there for an 8:30 a.m. setup to bring some supplies, but the actual event will last from 10 a.m. to 2 p.m. Yeah, the location and the address is here, and you can find it on the drive along with other presentations. I do ask that you please RSVP using the QR code found here if you are interested in attending. You don't have to be there at 8:30, but if you are, it would be greatly appreciated to help set up. But yeah, hope to see you guys there, and thank you.
Thank you, Robbie. Oh, we're clapping, yeah. Okay, yeah, we're clapping, yeah. Shout outs? You got it. Oh, yeah, I do that. Sorry. All right, yeah. So this weekly shout outs, we want to shout out a few people. We want to shout out Haley and Structures. You know, every single week, I always see a lot of members showing up for Structures and working on a lot of stuff. Always have something to do. So I just want to give them a shout out for their great work. Also a shout out for Tala in Propulsion. Her organization skills and hard work has been really good. If you look at the slides every single week, they're great. They're great. Just check them out if you can. Also a shout out for anyone who's is busy right now with midterms. I just want to wish you, we want to wish you good luck on your tests and hope you do good. All right, so for the icebreaker today, we want to do something kind of fun. We want to do a Kahoot. So this week is going to be the only week where this Kahoot is going to be a little bit different. So I guess for the future, all our Kahoots are going to be based on lessons we want to go over at the end of the meetings. So we're going to be going over every subsystem and just give y'all terminology and information. And then after the following week, we'll be doing a Kahoot. So this week, we're going to be talking some stuff about solid propellants and SCR propulsion. And the next week's Kahoot is going to be over that. But since we didn't do a lesson last week, I thought it would be fun to just do overrated, underrated fast food restaurants Kahoot. So y'all be able to vote on that and see what sucks and what's good. So do not put that code in. I don't think that one's right. So let me just start it right now. Let me see. So, all right, just give me 1 second, please. I worked really hard on this Kahoot, so hope you enjoy it. Also, for those who are in person right now, feel free to grab some pizza right now while we wait for everyone to get on the Kahoot. We have the plates in the back. We'll bring them right here. You can just get food right now.
You just roll. You roll bowls. I mean, as long as they're good. There were plates on the table.
Yes. They were on the table.
We got napkins, if anybody wants to come grab pizza. Y'all are welcome to grab as much as you want. Please start standing up. Don't leave me hanging here.
How do we get the?
You're hungry, grab. I think there also should be cheese. Chicken, like chicken.
Hey, how do you output the sound in here? I kind of want to output the Kahoot music. There's definitely a setting on Zoom.
Yeah.
Yeah, but
Should be. You can hear it.
Do we have a napkin? Y'all can figure it out. Y'all can figure it out.
Yeah, well, Jesus, did you hear?
Oh my God.
Where's Derek? It's playing.
Bro, what is this room? How'd you guys break it? You guys have one job.
Well,
this room.
Oh,
Yes, it's this room.
Oh, it's 2 or 4, right?
Oh my God.
What do we do? No, but when they talk, hey, can somebody talk in the Zoom right now, please? We just want to test out you again.
Yo,
Okay.
you hear it?
Yeah, we can hear you.
Hey, do you want?
I think it's a question in the chat.
What do you want? No, it's setting. It's setting like on the. Honestly,
Yeah, it is.
As much as you want. If you're hungry, you're hungry.
Eric's drink.
When the struggle is real.
Hey, true engineer.
Well, you got
Hey,
shit.
Joe, you sell your knife?
Y'all need one?
I know. Yeah, I kind of want to play too.
You're gonna play?
Yeah, we're gonna play. There's no win or anything.
I think you mean bias, I'm assuming, I don't have to know.
I don't have time.
Yeah, definitely bias. Thing is like, whoever, when Urban made this, when you made this, you like, is that a setting you can make?
To what?
There's no winner?
I mean, even if there is winner, it's like,
No, there's not like one winner.
I mean, sure, there's probably gonna be someone who's gonna, no, there is no winner.
There's no right answer.
There's no right answer. All of them are right, so it's just whoever answers fastest. Yeah, I mean, it doesn't matter who wins.
I don't think it matters for me.
Okay, is everyone ready? I think we're good. All right, so there is no wrong answer for this Kahoot. So it's just to see what everyone thinks of these restaurants. It's just for fun. There's no winner. There's no winner at all. Huh?
You're just wrong.
All right.
Definitely is wrong answer, so. For sure. It's definitely is wrong. No, it's not a right answer, but it's definitely a wrong answer. Absolutely. There might be some judgment. Exactly, right?
All right. All right, we're starting in 3, 2, 1. All right, so the first one here, just starting, right? It's Chick-fil-A. So what do y'all think?
Is there a right answer?
They're all right. They're all right. Yeah, they're all right.
Bro, who's never had Chick-fil-A?
Yeah, we're about to see how many people have never had Chick-fil-A.
I want their name at the top.
2 people, just right.
Hey, but nobody said it's underrated. So that's good.
Yo, that's surprising.
I was
It's really
definitely
surprising.
looking, but I never had it.
Hey, there's no winner, but that's fine. Yo, mom. All right. Burger King.
I'll say Burger King. He's up the right. But do people even overrated those? Yeah, that's, you even go to Burger King? Yeah. You've never had it. Going, I had it like once.
I feel like if it's overrated, it means it's bad. Like it might be.
I need Robbie's commentary.
I don't know.
You want the commentary, Robbie? Hey. Yeah, Robbie has the jokes. I have no jokes today.
You might be amazing. Did we figure out who Raj is? No cap.
McDonald's is trash.
McDonald's
Can I pick it?
It's like the last one.
Who's never had McDonald's?
Bro, they're not even human.
Bro, who hasn't had McDonald's? Can you speak up?
Hey, off the team right now.
You've never had McDonald's?
No, that was it.
We'll change that.
No, somebody hasn't had McDonald's. Okay. Dang.
Another fucking pizza.
Who said just chicken? It is chicken.
Urban to throw hands over this question.
He's throwing fingers.
You got the jokes too, Robbie.
Whoa, whoa.
You didn't even show the podium.
Wendy's,
Sauce is sauce is the best part of it.
the Cane's. Cane sauce is pretty good.
Sauce is the worst thing ever.
Yeah, Cane's without sauce is not
Sauce
good.
makes
Sauce makes
The chicken fingers from the Cane's be dry sometimes, bro.
Wendy's.
It's like the Popeyes. Overrated. What? Ooh.
Those frosted are trash.
Hey, Wendy's is pretty good.
Their 4 for 4 is good.
4 for 5.
4 for 4 is the best thing there. Absolutely.
Jack in the Box.
Oh god.
Everyone, nobody likes it.
Never had it.
You never had it.
Actually, I've never had it.
You never had it.
It's safe, but I voted trying.
It's average, I would say.
Jack in the Box is one of those places where you know what you're getting when you go to Jack in the Box.
What are you getting when you go? Trash.
100% hung over if you're going to Jack in the Box.
Hung over?
Hung over or drunk off your ass. if you're going to Jack in the
Just
Box.
right? Ethan said, I've always thought about to eat Jack in the Box.
That's my member representing Danny.
Yeah, and they always have issues with like salmonella and other stuff. Chipotle.
Never had it.
Oh, really? Nah, Chipotle is good, y'all. I would eat Chipotle every day if I could.
Tried Chipotle for the first time that y'all bought me.
Yeah, your order at Chipotle is like rice and chicken.
That was my first time having Chipotle.
Over what? What? Yo, what? No, why you doing? Oh, I'm hurt right now. I'm hurt. All right. What's next? Oh, In-N-Out. In-N-Out. I'm expecting a lot of never had it for In-N-Out.
I think it's overrated.
Bro, all of y'all are tripping right now.
If it's not 100% red, put it right now.
Bro, the only reason you don't like it is it's from California. Sonic is better. Hey, somebody said Sonic is better than In-N-Out.
Whoa! That is.
I'm walking out. That is out of pocket. I'm gonna walk out. Hey, take over.
All right. Hey, get out of here.
Hey, oh look, you made me click away. Look. Here we go. All right, so we got 2 more. I don't remember what's next.
Those are good.
Oh, Wingstop. Nah, this was overrated. Yo. This is overrated. Yeah, it's overrated, man.
I think it's
Dude, especially if you get boneless. If you get boneless, if you're getting boneless, you're a kid. I'm sorry.
Hey, listen, as someone who works at a wing place, I prefer if you order boneless. I hate people who order traditional.
So Wingstop, just right. All right. Never had it. All right. All right. The very last one right here, and there's only one right answer for this one, because I said so, is Whataburger.
Oh, there's only one. Yeah, there's
Trash.
the right answer is never had it.
It's garbage. I'm sorry. I can't. I can't do Whataburger. Yeah, let's go. Overrated. It's only the right answer for this.
Who's never had Whataburger?
Wait, who's never had Whataburger?
They're doing it right.
They're not doing their own work.
All right. All right. I hope you all enjoy the cahoots. Let's see. Let me see. Yeah, let me see who answers the fastest.
There was only 48 people. I don't think I answered.
Huh?
Go Joe. This Joe.
He wants to do a lesson right now. All right, so right now we are moving on to
All right. So we're introducing something new. So every week from now on, we want to have some mini rocket lessons. And so every week we want to have these little rocket lessons where you're learning about each particular subsystem. And so the lead from each subsystem is going to come up and like give a little presentation about what their system is, how it works, and kind of just all the things that go into it. Today, it's going to be SCR Propulsion who's giving their little presentation. And then the Kahoot for next week is going to be their little Kahoot. So it's like vocab words and just cool facts that you may have learned from Ozzy's presentation. Then the following week, just so you have it like in your calendars and on the front of your mind, would be avionics. And then the week after that would be structures.
and there will be a winner for the following weeks, and there might be a prize if you
Yeah.
win.
So
Not this one.
pay attention, and I hope you guys learn something so you can win. And so we'll hand it off to Ozzy so he can give a quick presentation over the fundamentals of solid motor propulsion.
All right, can y'all hear me? Can the team hear me?
Sure can.
Everyone? All right, awesome. Yeah, so I am going to give you guys a little lesson on solid motor propulsion, just some of the basics, nothing too in depth.
You did it wrong.
What's up? Okay, go ahead and go to the next slide. So yeah, one of the cool things about solid motor propulsion is although we do work on it in the lab, many people have this idea that it's kind of like hobbyist only. But if you guys actually take some time to look into what kind of solid propellants are being used in the space industry, you'll notice that it is almost exactly what we use in the lab and what we use to fly our rockets. So it's really something that kind of introduces you to the space industry. Like we're working on the same thing, basically what that these space industry companies are working on. Go ahead. These are just a couple of those are just a couple of what's it called, GIFs and pictures. You have the Atlas V. The bottom left is the Ares IX space shuttle, if you guys have never seen one. And then there's a missile on the right. All of them use the same propellant. So go ahead. Okay, so some of the simple principles of operation. Of course, you have a solid propellant motor. It is an extremely simple motor, relatively speaking. You have no valve control systems, no liquid propellants, no pressurized chambers. It's literally just a solid piece of fuel inside a motor casing with a nozzle at the end that will accelerate the combustion gases out the back and give you your thrust, which leads to acceleration. So one thing to notice about solid motors is that they are extremely powerful. Here's just a fun fact: a solid rocket booster for the shuttle is actually twice as powerful as one of the F1 engines from the Saturn V. So just to give you a little bit of insight on how powerful solid motors are. Main downside though for solid motors are the fact that they cannot be throttled and they are impossible to shut off once ignited. So it's as soon as you light it up, it better be pointing up. Go ahead. All right, so as many of you guys know that we do use a solid propellant motor in our Oberon rocket. It uses an Loki M3000, which has about 9.5 pounds of a ammonium perchlorate based propellant. It is called white lightning, and it is called white lightning because it has a distinct white flame and produces a heavy amount of smoke. So it's very easily visible in the sky. One of the cool things is the fact that this motor is extremely popular because it simulates real life solid rocket booster solid rocket boosters off like space shuttles and stuff. It simulates that that type of motor. The only difference between our motor and the solid rocket boosters that you'd find on like in like NASA or the space shuttle is the fact that ours does not have an iron oxide catalyst. It does contain 7 Bates grains, which are shown on the bottom right, which offers a neutral thrust performance. We'll get more into that in a second. Go ahead. Okay, so one of the coolest things about solid motors is the fact that you can actually change the geometry of the grain inside the motor. Changing the geometry will actually give you different thrust curves. This is important because once you start going into, 2, 3, 4 Mach speeds, you'll go through something that's called maximum dynamic pressure. If you guys don't know maximum dynamic pressure, it is the point in a rocket's trajectory where it experiences the most aerodynamic forces against the rocket. It's important to learn about grain geometry because you can basically have a specific geometry to decrease the thrust at a specific point in time relative to the max Q and then accelerate again afterwards. And here on the bottom right, you can see a couple of charts, thrust graphs relative to their grain geometries. Top right is actually a simulation. The left one is the Bates grain, which we use, which is just a neutral burn profile. And the right one just goes to show you how just offsetting it a little bit will give you drastic changes in performance. Go ahead. Okay, so fuels. We do use ammonium perchlorate. It is a composite fuel, the second from the bottom. Consists of ammonium perchlorate as an oxidizer, aluminum as the fuel, and polybutadiene as a binder or a resin to hold everything together. There are other fuels, for example, black powder. That's usually what you see in firecrackers or any, just heavy, just really, really low performance rockets. There's zinc sulfur, which is an interesting one because zinc sulfur will actually combust outside of the combustion chamber. So it'll make a distinct orange flame or smoke coming out of the bottom. Of course, if you guys have any, done hobby rockets, you guys have heard of candy propellants. It is basically just potassium nitrate as an oxidizer and sugar, which could be dextrose, sucrose. I forget, there's another one I forgot, but just mix them two at low heat and mold them to however you want and it'll fly. There's double base, which is just another type of propellant. We'll never really get into it. And then high energy composite. I threw this one on there because if you want more performance out of our motors, they add HMX, which is basically the main component in C4. So really cool stuff if you do want to go faster. Now, do keep in mind that talking about certain fuel compositions is regulated. So, we always try our best to stay within the regulations for mixing fuels, and it's very important to stay within those regulations. So just be careful what you look up online or who you tell online, because we don't want to end up on a list somewhere. Just teasing. It's really not that bad, but it is regulated. So it's really interesting stuff. Go ahead. Okay, so applications. Of course, you see on the top right, we have the two sections from the solid rocket booster for the space shuttle being joined together. It is not far from what we do in the lab whenever we're assembling the rocket. And I believe they use just a little bit more fuel than we do. So just keep that in mind. So solid rocket motors have many uses in the space industry. They have been crucial for the development of different orbital class rockets, as far back as the 60s and 70s. I mean, it's always been in the space industry. For example, on the space shuttle, it provided more than 80% of its thrust to get it into orbit. There are really cool applications like the Ares IX, which is on the right. They literally got a solid rocket booster off the space shuttle and used it as the main stage propellant for the Ares IX rocket. So just goes to show you that even though you have a solid rocket propellant, you can still apply it into the space industry and get a very good rocket out of it. Okay, once again, solid fuels, many people kind of see it as a hobby grade material, but they are still being used today. For example, on the Atlas V and the Space Launch System, they both use solid rocket boosters in its design. Go ahead. Okay, so this little lesson was more of a simple lesson, just kind of going over everything that is solid motor propulsion. If you guys are interested, there is a rabbit hole of physics, math, organic chemistry, and fluid dynamics that you can go into when looking at solid propellant motors. You can study, fuels and propulsion systems your entire life and still not learn everything there is to know. Do keep in mind that this was more of a less basic lesson, so we didn't go over any chamber pressures, mass flux, nozzle geometry, port to throat ratio, impulse, volumetric loading. Really, all of that stuff I mentioned is very important for the development of a solid motor. If you guys are interested, you guys are welcome to talk to anyone on the propulsion or the SRAP propulsion team, and we can go more in depth. But in the grand scheme of things, this is basically what you need to know. So don't mind the last sentence. That was for my team, but I am hoping to make a hybrid rocket motor lesson and a liquid rocket engine lesson. To I'm looking forward to those. But yeah, those are the basics of solid rocket motors and propulsion systems. Let me just go over the pictures real quick. On the right side, right top, you can see more or less an idea of what the nozzle geometry looks like. If you guys know anything about nozzles, solid rocket motors use a very simple converging, diverging nozzle. Just basically means there's a shallow angle to converge the gas and a sharp angle to diverge the gas into the atmospheric pressure. And on the bottom right, there's a test of one of the solid rocket boosters for the new SLS. So yeah, that's it for my lesson.
Thank you.
Thanks, guys.
Thank you, Ozzy. That was great. So next week, our Kahoot is going to be over everything that Ozzy talked about today. So be prepared for that. All right, so let's go back. All right, so now we're going to move on to sub-team updates. Every week we do sub-team updates to give everyone a general idea of what we've worked throughout the week. But right before that, Gustavo's going to talk a little bit over our PDR and what the PDR is.
Right. So what is a PDR? PDR stands for Preliminary Design Report. And so we are a team that is going to compete in New Mexico this coming June. And one of the things that they need is a lot of documentation in terms of what we learned about the rocket over like our construction, all the parts of the rocket and why we decided to do the things that we did, so on and so forth. But more importantly, we have a lot of people who have been part of the team in the past who are also really invested to teaching us everything that we don't know. And so a lot of those people, including Randy, which is our mentor from Tripoli, the rocketry organization outside of UH, he, along with alumni and any other interested party, are going to come and try to critique kind of our designs and everything we've come up with since the summer for Zenith. And so to kind of give a presentation of what we have come up with, we want to have a PDR or preliminary design review. So that will be happening on the 19th and 20th. So that is of November. So that's a Friday and Saturday. I don't remember the times specifically, but we can update you guys on that. For the PDR, we want to include a written document that has all the details and everything written out. It doesn't have to be to the nth degree of detail, but just a good picture of what we've completed and what's included into all our decision making. And then finally, a presentation. So we just be putting together some slides and stuff to actually present it to anybody who comes to our presentation that Friday and Saturday. We will expect that the written report and these slides and everything is done the week before. So it's going to be due the 13th, I believe. So that Saturday we want to have it done so we can send it out to all of our people that are interested or already interested in coming, and let us know so that they have an opportunity to read over it, prepare some questions if necessary, and then just be prepared for our meeting. And so, yeah, just to sum up, we want to have our PDR on November 19th and 20th. The 19th will be for the COT system or the commercial off-the-shelf system. And the 20th will be for SRAD, so student research and design. So anything that we're making ourselves hands-on from scratch would be presented on that Saturday, the 20th. And then all the documentation that we're going to present and compile together, that'll be due the 13th, so the Saturday prior. So yeah, I think it's really exciting. It just goes to show how much progress we're making towards our flight in June. So I'm excited to see where that takes us.
All right, thank you, Gustavo. Basically, yeah, PDR is just a validation of our rockets. It's going to be really important. More updates on that coming next Tuesday. So now, finally, some team updates. First off, avionics. B is going to present what they've done throughout the week. Yeah, B, let's go. Go.
Can you guys hear me? Awesome. So avionics. This week we kind of went over our COT system ground station with everybody. So for those of you guys who are kind of unfamiliar, avionics has two major flight computers. We have the telemetrum as well as the stratologger. And the stratologger doesn't really offer us a lot of information or any form of live data. So the telemetrum is kind of what we focused on here. And we kind of showed all the information that was available to collect during flight, all the information that is happening live and what it would look like if it was happening live, because there's a replay feature. Just so everyone is kind of familiar with that moving forward. We talked a little bit about the avionics bay CAD. So we have to redesign our avionics bay to fit the tele-easy that we have, because currently our stratologger is broken and we're hoping to get a new one, but in the off chance that we don't, we would like to have a proper bay design that is CADed for the tele-easy. So that's something we talked about, and we're hoping to get that done within 1 week ideally, but we set a deadline for about 2 weeks. And then we started to outline some of the concepts for SRAD for all the new members. So a lot goes behind developing our SRAD systems for avionics. A lot goes behind developing our SRAD systems for avionics. And I don't want to throw any of our new members in without any familiarity, especially on our COT systems. So I've been really doing my best to kind of outline all different parts of the different COT systems so that everyone's familiar with what we'll be doing and what some examples are in the real world, things that other people have built. So that way we can start getting into SRAD in these coming weeks. And attached is a picture of a Teensy 4.1 on the left and then a 3.6 on the right, because they're both architectures that we'll be using.
Haley, structures.
So over the past week, last Friday for our meeting, we worked on installing and teaching our members OpenRocket, as well as doing like a mini power tool session. We did both of these things with the previous members, then with our new members, we wanted to give them a chance to do that as well. It wasn't as in-depth as the first one, so we're still gonna be kind of like just, I guess, checking in every once in a while, make sure people are caught up on all the power tools and everything. As for tasks in progress, we are returning to the MMM designs. So if y'all were here before the new recruits, you saw that pretty much every week we were talking about MMM designs. We're going back to that now. And then this one right here in the top left is Gustavo's new design that we're adding to our ranks of various designs that we have going on. We have Brandon working on the open rocket for Zenith just to give rough estimates for sizing. We're looking at pricing for 6-inch manuals so we can start practicing on those for composite airframes. Looking at pricing for upper and lower airframes in fiberglass, as well as nose cones in the 4 listed options. And then based off of the top right chart, since we're going about like Mach 2 approximately, those are the options we've chosen so far. And then once we have a bit more information on them, we'll be handing them over to analysis. I guess we'll try to limit it to like 2 or 3, and then we'll hand them over to analysis, and they'll go ahead and have a chance to run some FEA on them.
Yeah, great stuff. Tyler, I don't know if you can.
How's my audio?
Sounds great.
All right. So for 30K propulsion, it's been mostly a slow week. One of, I guess, the major updates that we have is that I met with our project manager, Irvin, to just discuss kind of a realignment of what 30K propulsion is going to do in terms of our goals and projects, just because the main thrust of our work is mostly complete because we do finally have a chosen motor in addition to a backup motor. So until we can order that and our motor support equipment, our job is pretty much done. So we discussed adding new goals and projects, having like a small mini sort of SRAD component to 30K propulsion. Some more details on that are probably going to be finalized by our next meeting, but I am excited for that. As far as just general housekeeping updates, we do have a finalized lab time. So it's going to be Wednesdays and Fridays with those times. And we are going to have a little lab tours for any propulsion members that can't make those times. So yeah, everyone hopefully should get a chance to see the lab, see last year's work, and we're going to start our new projects. So yeah.
Thank you, Tyler. Robbie's coming up.
All right, for analysis this week, the main thing I kind of wanted to get started with the new members was actually downloading the Siemens software and the fun process that is. And we've already run into some hiccups with that, unfortunately. So I'll be reaching out to Chris Penny, our advisor at Siemens for the software. For the design team, I guess we renamed concentrations into the design team and validation team. Their PDR objectives is to get a preliminary CAD of Zenith and that whole model, what that kind of looks like, some potential designs. Finally, do an FEA of the MMM, which is something, as Gus was talking about in the PDR, that the alumni have been asking for us for a while now. So finally, with analysis, we can provide them that. And then also looking into an airframe buckling analysis and how the airframe may respond to different forces during launch. And then on the other side with our validation team, they'll be working on an open rocket and a RockSim design to kind of give us one value with each program so we can hopefully get a more accurate predicted apogee. And then also a project we've been thinking of for a couple of weeks now is defining unit system. In the past, the team has been kind of non-consistent with different units for different measures. So my idea was to try and look at the different, I guess, components of what we quantify and define an official unit system for each of those categories so that we know what to keep all our units in, and that will massively help us out once it comes to the technical report and even the PDR and maybe the CDR. Some onboarding projects that I've been assigning to our new members for the design team, just trying to create a CAD model in NX, kind of get their feet wet with that software. Shout out to Arturo. He designed this nose cone based off of Oberon already in NX, so he's been killing it. Then with our validation team, an open rocket design just from scratch, and then try and just build an open rocket to reach 30K. But yeah, that's analysis for this week. Thank you.
Next up is Fernando with recovery. Sorry, Carlos.
Hello, everyone. So this this week for recovery. So what we did is we first went over some tasks and milestones. So that was basically laying out the important decision analysis and validation tasks that have to be done going forward. We also started a CO2 system research where we're going to be looking over 4 different CO2 systems. And we're gonna kind of fill out a spec sheet that you can see there on the top right. And we're probably gonna add a little bit more to that, but that's just gonna help us look at different CO2 systems to make sure that we pick the most desired one for CNID. Also this week or last week, we went over our first week of onboarding presentations. So we went over spaceport, IRECT, recovery design guidelines, and recovery configurations. And upcoming this week, we have the second week of the onboarding presentations. We went over the first round today before the meeting, where we went over black powder, CO2, and mechanical separation systems. That's it for recovery. Thank you.
And I don't know if Ozzy, you're still here.
Yeah, I'm still here. Can y'all hear me?
Yeah, we can hear you. We can hear you.
Okay. Sorry, guys, I'm driving. But yeah, I can give you guys a little update. Okay, so if you guys can still hear me, so I do apologize that the slide is actually last week's slide, but it's good that that the schematic is up there, because we actually do have some changes that we can reference that schematic. So one of the main changes.
Ozzy, your audio is cutting off right now. I guess we can just update everyone next week, or we can send out a message about your update. But thank you so much, Ozzy. Thank you a lot for that presentation. Let's give him another clap.
All right, cool. I'm sorry. You guys can
Ozzy,
still hear me, right?
yeah, but we're gonna move on right now. Thank you so much.
Oh, okay, no problem. No problem.
Yeah, it's all good. It's all good. I guess right before the questions, just a general message to all members. I know that's a lot of information for all the sub teams. So don't be afraid to take your time to ask questions, to just talk to your sub team leads about anything. If you are really busy over the week, just communicate with us. And I guess in the next 2 weeks, it's when the real work is gonna get started. I know for the last 2 or 3, it was just onboarding new members, but now is the time to actually build this rocket and complete it, and hopefully get an amazing launch in June. The PDR is gonna be important, so we're gonna be working on that for the next month. It's gonna be great, and yeah, thank you so much for all the hard work throughout the last few weeks. All the new members, old members returning. Any questions now?
What's an FEA for them? I don't know. You want to? What was it? Analysis.
Sure.
You're gonna have to do it up here, so.
So the question was, what is a FEA of an MMM? Right, is what I explained.
Okay, so I guess the first thing to define is the MMM itself. The MMM is a modular motor mount. I'm sure you've seen it in the lab, maybe. Haley is redesigning it for Zenith. Okay, keep talking. So an FEA is a finite element analysis. If you want more specific information, you can look at some of analysis's slides from the last meeting. But essentially, what it is simulating forces on a CAD model. There's a bunch of different ways that different programs attack it. The way the Siemens software does it is pretty much common to some other programs, but they'll split up your CAD model into a finite number of elements and then run the analysis on those different elements and then solve all of those and then display it back to you as to what's going on. And it'll give you different results for different types of forces and different stuff. So, and the reason why we wanted to do that for the PDR is because the alumni have asked for it in the past because we hadn't flown with a redesigned MMM yet. So they wanted some validation as to how you guys know this is going to work.
I think I asked Ozzy about that actually. I was like, how do you choose this new design here?
Yeah.
And he was like, well, we haven't checked.
Yes.
We had a guy grab it and try to break it. It didn't break.
Yeah, so we weren't able to really tell the alumni like with 100% certainty that it was actually going to work in flight. We just kind of knew based off of its structural rigidity, but now we can actually get some numbers behind that. So that's what we're working
on. Claps. Yeah, it is a form of validation to make sure that nothing's gonna break on the MMM, especially this year since we want to minimize weight. It might be weaker and we want to see how much we can push it. Any other questions? No? I saw Alex pointing at you for a question.
Yeah, so in Ozzy's presentation, he mentioned that
Go on, Alex.
All right, so Ozzy's presentation, he mentioned that NASA people, they have an iron-on catalyst in their solid rocket. So what is the benefit of having iron oxide?
All right, that will be an Ozzy question. Ozzy, are you still here? He is not here.
He's currently going to 120 right now.
He's not here. But as always, you can always reach out to him on the Discord and get a very detailed answer from Ozzy or any other questions from any sub-team leads. Any other questions? That side of there, no questions? No? Let's check the chat. No questions. That's it for this week. Again, thank you everyone for joining online or in person. You've been doing great, and we'll be seeing you next week and throughout the week with your sub-team leads. Are the slides gonna be on the Discord? Yeah, it will be on the Discord.
Also the drive.
And then the drive too. All right, thank you all.